In this video, we're going to be solving for work using two different methods. So we have a 5 kilogram block at the bottom of a ramp that's pulled up 8 meters. Now for work, we are going to be doing the force times the distance. Now, if we were taking a look at the forces acting on it, something is pulling it up here, so we'll just call that maybe an FA, an applied force. We have the normal force perpendicular to the surface, and then we also have the force of gravity pulling straight down. Now, we'll just assume that the block is being pulled at a constant velocity, so the FA would equal the amount of force that needs to be counteracting this force over here, which we'll call FGX. So we're going to create a little triangle underneath our 5 kilogram block where our 30-degree angle is going to translate right there. And our FGX is the portion of gravity that would have the box normally sliding down the ramp, and our FA is going to be that force that counteracts it. So we're basically saying our FGX equals our FA in order to pull the block up at a constant velocity. So in order to solve for that, we're going to go ahead and solve for FG, which is mg. mg is mass times 9.8, and then that gives us 49 newtons. Now, we're going to take that 49 newtons, and we want the opposite end of that 30-degree angle, which is going to be the sine of 30 degrees. So we're going to take 49 times the sine of 30, and that's going to equal 24.5 newtons. All right, so now that we got that established, that is the force that we're looking for, and we know that it's pulled up a distance of 8 meters. So method number one, we found that force that it's being applied, pulling it up the ramp, and then we're going to take that 24.5 newtons, multiply it by the 8 meters, and then that would leave us with a final value of 196 joules. So that's the amount of energy transferred to the block to lift it up this 8-meter slant. Now, method number two is a little bit more conceptual and then less mathematical. Now, we know it's being pulled up 8 meters along this ramp, and it's reaching some kind of specific height here. And if we use a little bit of trig, we can use sine, because sine gives us the opposite over the hypotenuse end, so which would mean the sine of 30 degrees equals the opposite over the hypotenuse, multiply both sides by 8, and then your height equals 4 meters. So assuming that the block is starting at ground level of 0, which it is, and then increasing to a height of 4 meters, then the work is going to equal the change in energy. The change in energy is going to be the change in the gravitational potential energy from a height of 0 up to a height of 4 meters. So we have a final height of 4, but the mass is 5. The G value is 9.8 as usual, and then we're going to plug in that 4, and that gives us 196 joules as well. And the reason why that works is because work is the amount of energy transferred. Solving it the green method tells you how much energy is transferred by finding that exact force and the distance it's actually pulled parallel to the ramp. And then our red method is simply looking for the change in energy or the increase in energy because of the work done. And because it goes from 0 to this number, that means it's an increase, or a delta UG of 196 joules. Therefore, the work is 196 joules. So two different ways with two different mathematical components. As I said, the green part is maybe a little bit more math intensive. The red part is a little bit more conceptual, but basically, depending on what you're given in the particular problem would probably lead you to one of the methods. But in certain problems, you could potentially use either one. So whichever one you prefer, go ahead and use it. So I hope that was helpful to you. Thank you for watching and listening.